Welcome to part 3 of invertible elements. Yeah, I know it's long, but it's worth it. Now, remember, during the previous lecture, we considered this theorem. Let P be prime. Then if D divides P minus 1, then the equation S exponent D is equal to 1 has these solutions in ZP. So today, I want us to solve questions under this theorem for you to better understand the concepts. So the first question that I want us to look at is, if you are being asked to solve x raised to the power 10 is equal to 1 in Z71. When you are being given a question like this, how do you solve it? First of all, the first thing that you have to check, remember, let P be prime. So let's see, is 71 prime? How do we check if 71 is prime? In checking this, we can always find the square root of 71. And the square root of 71 is 8.42. Now we then list the numbers that are less than or equal to 8. So in this case, we have 1, 2, 3, 5. Sorry. We are going to list all the prime numbers, all the prime numbers that are less than or equal to 8. So we are going to have 2, 3, 5, and 7. Then we check, does this 71 divide any of these? 71 over 2, 71 over 3, 71 over 5, 71 over 7. No. Since over here 2, 3, 5, and 7 are no divisors of 71, then we can conclude that indeed 71 is prime. Okay. Now, over here, we've now gotten to see that P is prime. Then if D divides P minus 1, okay. So now let's check. What is the GCD? The GCD of 10 in this question, our D is 10. So 10, and our P minus 1 in this case is 70. So in this case, the GCD is 10. So D divides P minus 1. So in this case, our D is 10 and our P minus 1 is equal to 70. So does 10 divide 70? Yes. Then the equation S exponent D is equal to 1. So x raised to the power 10 is equal to 1 has these solutions. So now over here, it has these solutions, meaning that the GCD of 10 and 70 is equal to 10. So we are going to have 10 solutions. I hope this is clear. Now, after getting our 10 solutions, how do we even get the 10 solutions in the first place? That is when we introduce what we call a generator. So the next step is we find a generator. And in finding a generator is a bit tricky, so please pay attention. Now, in finding a generator, we have to, over here, what we do, we have to let me write, to find a generator. We divide the number P minus 1 by the number of solutions. So in this case, P minus 1 is 70, and the number of solutions that we got was 10. So this is equal to 7. So our generator will be of the form A exponent 7. Okay. Now let's move on to the next step. The next step is, since our GCD of 10 and 70 is equal to 10, over here 10 is even. Whenever you find a GCD and you get an even number, that is when we are going to use the Lagrange theorem. So we use the Lagrange theorem. Please, this is very important. You have to pay attention to this. If the GCD is always equal to an even number, you have to consider the Lagrange theorem. Okay, the Lagrange theorem is asking, over here, since we have 10, we have to find the factors of 10, right? So we are going to get 1, 2, 5, and 10. But we do not consider the last negative. So now, what we are trying to say is that if a raised to the power L is not equal to 1, it's not equal to 1, 4, 1, 2, and 5, then it's indeed a generator. Okay, what do I mean by this? Remember, we got this a exponent 7 to be our generator. Now, to find our generator, we always start with the least prime number that we have, and the least prime number is 2. Okay, so if a is 2, we are going to get 2 exponent 7. Now, 2 exponent 7 modulo 71 is equal to 57. Now, since we've gotten 57, we have to check, does it satisfy the Lagrange theorem? That is, if you have 57 exponent 1, this is indeed not equal to 1. Okay, let's move on. 57 exponent 2, or in modulo 71. So 57 exponent 2, we are going to get 57 exponent 2 is modulo 71. That is 54. That is also not 1. Okay. Let's check 57 exponent 5. 57 exponent 5 modulo 71 is equal to 1. And with the Lagrange, is saying that all the numbers exponent L should not be equal to 1. So A, in this case, which is 2, exponent all the L, which is 1, 2, and 5, should not be equal to 1. But we've gotten to see that 57 exponent 5 is equal to 1, meaning that A exponent 2 is not a generator. Then we move on to the next prime number. So we are going to go to when A is equal to 3. When A is equal to 3, we are going to get 3 exponent 7 modulo 71, and that is also equal to 57. So meaning that this is also not a generator. Now let's move on to the next prime number, which is A is equal to 5. When A is equal to 5, we are going to get 5 exponent 7 modulo 71, and that is equal to 25. So now let's see, is 25L not equal to 1? Now let's see. So 25, 1 is equal to 25, okay? But we know that 25 exponent 5 modulo 71 will give us 1. So meaning that for A is equal to 5, this will also not satisfy. You see how it is? Now, if A is equal to 7, we are going to get 7 raised to the power 7 modulo 7 raised to the power 7 modulo 71, and that is equal to 14. Now we have to check if 14 satisfies the Lagrange theorem. So is 14 exponent L not equal to 1? Let's see. If you have 14 raised to the power 1, this is equal to 14. Now 14 raised to the power 2. So let's see, 14 raised to the power 2 modulo 71 will give us 54. Now 14 raised to the power 5 will also give us 70. So indeed, you could see that these three values are not equal to 1. So it means that the 14 over here is a generator. So we got to see that 14 is a generator, meaning that our generator will be of the form 14 exponent k, where k is a subset of 0, 1. Since we have s raised to the power 10, we are going to get to the exponent of 9. And this is equal to 14 raised to the power 0 is 1. 14 raised to the power 1 is 14. 14 raised to the power 2 is 54, all in modulo 71. Then 46, 5, 70, 57, 17, 25, and 66. So now these are the values that satisfy the equation s raised to the power 10 equal to 1 in Z 71. So if you, for instance, if you pick this 25 exponent 10, this should be equal to 1 in Z 71. Okay, now let's move on to the second example. So example 2. X20 is equal to 1 in Z 73. The first thing that you have to do is to check is 73 prime. 73 is indeed prime. Okay, if it is prime, then what is the GCD of 20? And 73 minus 1 is 72. And that is equal to 4. Which means that we have 4 solutions. Okay, now remember 4 over here is even. So what are the factors of 4? The factors of 4 are 1, 2, 4. We don't consider the last case. Always remember this. Now the next step is to find our generator. So in finding our generator is always P minus 1 dividing the number of solutions, which is 4. So we have 72 over 4, which is equal to 18. So our generator will be of the form a raised to the power 18. Okay, so we have a raised to the power 18 to be our generator. We always start from the least prime number. So if a is equal to 2, we are going to get 2 raised to the power 18. And 2 raised to the power 18 modulo 73, this is equal to 1. And this can't satisfy the Lagrange theorem because 1 raised to the power L will always be equal to 1. So this is out. Now if A is 3, we're going to get 3 raised to the power 18 modulo 73, and this is equal to 72. Now we have to check if 72 raised to the power L is not equal to 1. Okay, so our L in this case, we have 1 and 2. So 72 raised to the power 1 is 72, but 72 raised to the power 2 over here is 1. And this is what we don't want. So this is also not a generator. Let's move on to if A is equal to 5. We are going to get 5 exponent 18 modulo 73, and that is equal to 27. Now is 27 exponent L not equal to 1? We have to see. So 27 raised to the power 1 is 27. Then 27 raised to the power 2 is 72. So indeed, you can see that from these two values, none of them is equal to 1. So A is equal to 5. Satisfy the Lagrange term, and that was equal to 27. So our generator is 27, and that will be equal to 27 exponent k, where k is from 0 to up to 3. Okay, so now we are going to get, when k is equal to 0, 27 raised to the power 0 is 1. When k is 1, we're going to get 27. When k is 2, we're going to get 72. And when k is 3, we're going to get 46. So the four solutions satisfying the equation are 1, 27, 72, and 46. So meaning that if you have x raised to the power 20 is equal to 1. For instance, if you get 46 raised to the power 20 should be equal to 1 in Z73. I hope this helps. Okay, let's move on to the last example. So if you have this, first thing I have to check is 113 prime. So 113 is indeed prime. Okay, now let's find the GCD of 35 and 113 minus 1, remember, which is 112. You can use the Euclidean algorithm to solve it. You're going to get 7. So we have 7 different solutions. Note that over here, this 7 is not an even number, so we can't use the Lagrange theorem. Okay, now if we can't use the Lagrange theorem, let's go to the next step. The next step is finding the generator. So in the generator, we are going to get p minus 1 dividing the number of solutions, which is 7. So p minus 1 is 112. 112 over 7. This is equal to 16. So our generator will be of the form a raised to the power 16. And because we can't use the Lagrange theorem, what we are trying to do is a raised to the power 16 should always not be equal to 1. Your generator should always not be equal to 1. Let's see. If we pick the smallest prime number, which is 2, so when a is equal to 2, 2 raised to the power 16 modulo 113, and this is equal to 109. Now, since 109 is not equal to 1, it means that it is a generator, straightforward. It's as simple as that. So the generator in this case is 109. So we are going to get this 109 raised to the power k, where k belongs to how many over here? So we are going to get 7 solutions. So 0, 1, up to 6. Okay. So our generator 109 raised to the power 0 is 1, to the power of 1 is 109, 16, 49, 30, 106, and 28. So these are the values that satisfy the equation s raised to the power 35 is equal to 1. meaning that if you are to pick any of these numbers and place it where s is, so 30 raised to the power 35 should be equal to 1 in Z113. I hope this helps. The last thing that I'll do is to give you a try work for you to do. I'll provide the solutions in our next video. So try work. 1. Calculate 8 raised to the power 999 in Z33. 2 is calculate 7 raised to the power 3444 in Z42. And the last one is solve x raised to the power 20 equal to 1 in Z61. I hope this video helped you. Please, if you enjoyed this video, like, just share, subscribe, and if you don't understand anything, just leave a comment. See you later in the next video. Bye.